Okay, so let's now have an example on the stages, but we focus this problem uh, in the determination whether the beam is cracked or uncracked. Okay, so this problem focuses on the procedure and how to determine whether the beam is cracked or not. So assuming that you have a rectangular beam, 200 by 400 millimeter in dimension, and the beam is simply supported having a span of 4 meters and having a uniform load of 10 kilonewton per meter. Okay, so your material properties are given. So these are the material properties. So the first step is to solve for the maximum moment of the beam. Okay, so the maximum moment can be directly solved by using a formula, or you can solve it using the shear and moment diagram. Okay, so if I have here the beam, since this beam is only simply supported, I have a 10 kilonewton per meter load, 4 meter span. I can readily solve for the reactions. Okay, so due to symmetry, okay, your R here, R1 and R2 are just equal. Okay, so R1 equals R2 equals 10 times 4 divided by 2, which is simply 20 kilonewton. Okay, so if I draw now this shear diagram, I go up 20, then this is a uniform load, so 0 degree, so this is a negatively directed load, so it must be downward, uniform slope. Okay, then you go up, so this is 20, negative 20, and your final moment diagram now becomes, since this is at the middle, so the area of this, the shear area here, is actually the moment there. Since this is a first degree curve, this must be parabolic curve. Okay, so that's how you draw the moment diagram. So what's the area of this? So the area is of this diagram here, area of the shear diagram is equal to 1/2 20 times 2. Okay, so this is 2 meters. So the area now is simply equal to, cancel, 20 kilonewton meter. Or you can readily solve this moment, the maximum moment here, by simply using the formula WL squared over 8. Okay, so the second step now is to solve for the modulus of rupture, or the cracking stress. So the cracking stress and the modulus of rupture are just the same. So from the formula I showed you a while ago on the first video, so Fr is equal to 0.62 square root of Fc prime. So this is your Fc prime, which is 20. So your stress now becomes 2.77 megapascal. So this is the amount of stress that the concrete can hold before it cracks. Okay? So the modulus of rupture simply gives you the maximum stress that the concrete can withstand before it cracks. And we have to compare this to the actual flexural stress at the tension fiber. And we know that in your strength of materials, okay, your flexural formula is simply F is equal to mc over I, where m is the maximum moment, c is the distance of the fiber from the neutral axis, and I is the moment of inertia. So the moment of inertia of the cross section is given by the formula 1/12 of BH cube, which is only applicable to rectangular cross section. Okay, and your I now can be solved using the values of B and H. We computed it to be this value in millimeter to the fourth, and your C is simply the distance of your neutral axis to the topmost fiber, which is in tension. So your tension fiber is at the bottom, so this is your C equals simply H over 2. Okay, so H is 400, and you divide it by 2, you get 200 millimeter. So F now becomes 20 times 10 to the 6 is the moment. This is the distance C, and the moment of inertia, you get now 3.75 megapascal. Okay, so we compare the two. Ft or F is compared to Fr, or the modulus of rupture, or the cracking stress. And we note that F is greater than Fr. Therefore, if the actual stress, this is the actual, exceeds the limit stress, or the cracking stress, which is the limit at which the concrete material can only the concrete material can only withstand. So we now conclude that the section is cracked. If it so happens that this is less than that, then the section is not cracked. So question, what if they are equal? What if F is equal to Fr? So still, the conclusion is the concrete will crack. Okay, because it's on the exact value of your modulus of rupture. Okay, so on the next video, I will be going to teach you how to do an exact analysis of the uncrack and the crack stage after checking whether your beam has cracked or not. Okay, so this will be our next topic for the next video.